This is Stuart Cheshire. He got his undergraduate degree at Cambridge, and then we were inflicted with him at Stanford. And then he's head of networking at Apple, and he invented zero configuration networking. And of course, marketing people have changed the meaning twice.
Thank you, Anna. I'd like to start off by asking for a quick show of hands. Who here has heard me give presentations about Bonjour or ZeroConf before? Okay, just 2 or 3, that's good. So I won't be boring too many people then. I want to remind everybody here that this is the first of the Google Tech Talks that is going to be recorded and published on Google Video on the public internet. So you're free to ask any questions you like, but don't ask any questions that relate to proprietary, secret Google projects that you don't want the public to know about yet. So I'm Stuart Cheshire, as Anna said, and zero configuration networking is something I've been working on for almost 10 years now, really as a result of the frustration I had with networking devices and computer devices that were just too hard to use. And it wasn't such a hard problem to solve. I just got tired of waiting for somebody else to do it and decided I was going to have to do it myself. I want to thank Tim O'Reilly, who's been a huge supporter of this and recognized the potential here and persuaded me to write a book about it, which is coming out next month. It's already appearing on Amazon. We don't have a cover picture yet, so we don't know what the animal's going to be. I mention that because it's the question everybody always asks me. No, I don't know what the animal is yet. But he's been a huge supporter and has done a lot of work evangelizing this. So the goal here is that I want network devices to be like buying a table lamp. You plug it in, you turn it on, it works, right? Nobody ever has a table lamp that doesn't work because they didn't configure the subnet mask correctly. It's just insanity. And AppleTalk did this 20 years ago. So we know it's technically possible. It's just that the IP community didn't care about ease of use like that. I mean, to be honest, if you were running a Unix machine 10 years ago, you had bigger problems than worrying whether you got your subnet mask right. There were harder things to configure than that. So what do we mean by ZeroConf? What I'm going to be talking about today, I expect right now immediately, will be of sort of academic interest to this crowd. I expect most of you here are out of curiosity because what Google does today with Gmail and Frugal and web search is very resolutely at the grand scale of networking, of big data centers and global scale networking. And I really inhabit the complete opposite end of the spectrum, where it's literally, it's as simple as 2 laptops plugged together with an Ethernet cable and they want to communicate. And the wide area networking right now with the excitement about the web, I think is being served pretty well, but it's the local area stuff that's being badly neglected. So we're interested in a couple of laptops, maybe an Ethernet hub and a printer, maybe some wireless networking, and of course we'd like to scale this up as far as practical, but we're not trying to compete with today's managed infrastructure networks, because when you get to a network of 100 machines or 1,000 machines, you start to need some kind of policy and management, and we're not trying to compete with that. The kind of things we're aiming at, and I've brought some demo gear along here. One of the fun things about this is that whenever companies make ZeroConf products, quite often they give me one for testing, and we do a bit of debugging, and then I end up putting it in my demo bag for afterwards. And everything here except one is actually not an Apple product, which is the other thing that makes me really excited, is we could do AppleTalk all over again at Apple and nobody would really care. But getting the message out to the broader community is what's important. So a lot of these things are low cost, very limited memory, slow processors, and that means we need a simple solution. And many people have recognized the difficulty of ease of use in IP networking, but the problem is they couldn't rein in their ambition to throw in every feature they could think of, and you ended up with something that was unimplementable. I mean, sure, you could implement it on a desktop PC with a gigabyte of RAM and a gigahertz processor, but in simpler devices, even if you could make the code fit, the complexity of debugging it just turns out to crush this. When you're building a network protocol, the way to succeed is just uncompromising simplicity. Because if you're going to have an ecosystem of thousands of devices, the opportunities for mistakes and incompatibilities just mushroom. So you have to start off with something that's absolutely simple if you hope to succeed and solve that problem. This is a design principle I learned at IETF meetings, that a protocol is complete not when there's nothing left to add, but when there's nothing left to remove. And that's actually, that quote predates networking by a long time. That's a quote from a Frenchman, I think, called Saint-Exupéry, and it was a quote about aircraft design. And you'll see that in an aircraft, it definitely makes sense that it's complete when you can't think of anything else to remove. One question that I still have to ask after nearly 10 years, or the question I have to answer, is why IP? And I've laid out a goal right now of what we want to do in terms of ease of use. And there are many ways we could solve that. And the way that I believe is the right way is IP. So if we look back 20 years in the history of wide area networking, and most people in this room are probably too young to even remember this, there were many, many competing standards for wide area networking. And the good news is they all died, and they're all obsolete, largely forgotten, and TCP/IP is one. In the same area 20 years ago, you look at what you had on your personal computer, you had all these different connectors. And the good news is that those all have died and faded into obsolescence. But the problem today is you look at the back of your computer now, and it's still bristling with all these incompatible connectors and communication technologies, all for local area communication. And what are we, as a networking community, as an engineering community, doing about this problem? We're making even more different incompatible ways of connecting things. So my belief is that in the wide area, we can all see the benefits now of adopting a single standard technology that everybody supports. And the benefits of doing that in the local area should be clear. And I'll take a step even further and say the local area protocol should actually be the same one that we've adopted for the wide area. And some people in this room are probably thinking, he's crazy, that's stupid, you know, why would you want to be setting up all that configuration? And the little thought experiment here is, well, if we could make IP so it didn't need configuration, maybe it could do the job that we do today with things like USB. So what do we need to do easy networking with IP? Well, all of this is very straightforward and very obvious. And if you walk out of this talk today saying, none of that was very clever, that was really obvious, then you got the point, because that is really the message I want to get across. It really is straightforward and obvious. So to do IP networking, you need an IP address. You're not going to do much networking until you have an address, so that's the first problem to solve. Once you have an address, you can communicate, but human beings don't really want to be typing in numbers, so we want naming. And the third thing we want is the ability to browse the network and discover what's there. And traditionally today on an IP network, we don't have very good browsing, but AppleTalk did, and we want to get back to that level of ease of use that we had on small networks with AppleTalk. So, very simple solution here, because we want the simplest, most reliable, most easy to implement solutions. And again, a lot of the inspiration comes from the way AppleTalk used to work. Pick a random address, send an ARP request. If nobody answers that request, then you say, hey, no one's using this address, it's mine. That's how you allocate self-assigned linked local addresses in IP. After many years of wrangling and debate in the IETF, we published the RFC for that this year, so that's now an IETF standard, and it's very straightforward. These addresses are only good on the local link. Nobody on the other side of the planet can use that to talk to you. But if all you need to do is print a document from here to there, an address on the local link may be perfectly adequate for what you need. This first showed up in Windows 98 and Mac OS 8.5, so this has been around for 5 years now. And people are probably familiar with these 169.254 addresses, and normally when people see them, they curse and kick the computer because the network's broken. And it's understandable why people would think that, because you're kind of seeing one leg of a three-legged stool. And until the other two legs are in place, having a random IP address doesn't seem to buy you very much. IPv6 already has linked local addressing. What we're doing here is not competing with IPv6. We fully support IPv6, but we also recognize that many of today's devices still only do IPv4. Macs do v6, Linux does v6, even Windows does v6 now, but many of the lower cost devices that we want to be able to communicate with don't. So now we've got a bunch of random addresses. So in principle, the devices can communicate, but you don't want to be shouting IP addresses across the room and typing them in. So we want naming. Now we're following the same principle before of simplicity. Just as before we wanted the simplest way to get an IP address when we didn't have a DHCP server, we're now looking for the simplest way to do naming when we don't have a DNS server. So we use the same DNS query syntax, the same packet format, the same naming and record types, but we multicast it to every machine on the local link, and each device runs a little responder that's listening for those requests. And when it sees a DNS query for its name, it says, hey, that's me, and it gives a standard DNS response. And from the point of view of a DNS client, a resolver client, it barely has to know what has even gone on here, because it sent its DNS query to this address, 224.00251, which happens to be a multicast address, but the DNS client doesn't really need to understand what that means. And then you get a response coming back which has the answer in that you're looking for. So it looks very much like a normal DNS query, but without the server on the network. Now, there are some rules that have to be followed here. The devices have to cooperate with each other. If they both want the same name, then they both can't have it, and there's some conflict resolution that goes on there. But from the point of view of the querier, it's more or less a standard query. And that gives you now the ability to use conventional style host names in your web browser, on the command line. You can SSH to mycomputer.local, and all of those places that you would normally use host names today, you can now use .local host names. And just like with the linked local addressing, we carved off a chunk of the IP address space and said anything starting 169.254 is defined to be linked local scope only with no global significance. We did the conceptually similar thing with the DNS namespace, where we carved off a subtree of the DNS namespace and said that anything that falls under .local is by definition local significance only. And the upside of that is that anybody can use one of these names. You don't have to pay $35 a year or register it with anybody. The downside is that privilege that you have is also afforded to everybody else as well. So you have to, you trade off the central authority and the money for the requirement to at least collaborate and cooperate with the peers around you and not be hostile. In a hostile environment, this is not the solution you'd want. Multicast DNS showed up in macOS 9.2, in macOS 10. NICTA, a research organization in Australia, wrote the version for Linux as an NS Switch plugin. And in Bonjour for Windows from Apple, we have a name service provider plugin that implements .local name lookup as well. So that's good. We've got back to sort of feature parity with what people expect of internet networking, which is IP addresses and names that you type in. But you have to know the name, and you have to type it correctly. And if you mistype it, it doesn't work, and nobody really tells you why or suggests what you should have done. So what we want to do is even go beyond that, to just browse and discover what's on the network without having to know in advance. And I'm not claiming that we're the first people to think of this. The list of attempts to do discovery protocols over IP just goes on. I think every permutation of resource and service and discovery and location in all possible orders has been used. And when they ran out of those acronyms, they made up other ones. And why did they fail? Well, I think they all couldn't resist the urge to keep making things more complicated. And when you're building one client and one server, you can put them on a test network and test them and debug them. But when you're developing a standard that's going to be used by thousands of devices, many of which will never appear on the same network until that happens in some customer's home, the matrix for exhaustive testing of all combinations becomes impossible. And if you can't do exhaustive testing, your only assurance that it's going to work is to keep the protocol so simple that there's almost no way to make it go wrong. And there's always ways to make things go wrong, but you have to ruthlessly eliminate every possible opportunity for things to be misinterpreted or implemented differently. And it's a bit sad because we're not inventing this for the first time. We actually have AppleTalk to copy that sets an example of how this can be done. So I don't want to dwell too much on the failures. Let's talk about what we've done. So in this whole presentation, if there's one thing that I would say is not the obvious part, it's this. And that was the insight that we've already agreed that devices are going to need link local addressing, and they're going to need some kind of naming. So multicast DNS is the answer for that. Having agreed that these little devices have got to have those 2 bits of code in them, maybe we don't need a complete third body of code for doing discovery. Maybe we can actually repurpose some of that code that they have to have anyway. And that was the breakthrough, realizing that we can do service discovery using the semantics of DNS queries, and we don't need to invent a new protocol. And then we can run that DNS over the multicast DNS support that we've already created. And the insight here is that we can put together some existing properties of DNS that are not new, they just haven't been used in this way before. And one of those is that a DNS query can return multiple answers. If you have a multi-homed host, you do a query, you get more than one IP address. This is normal. Another function of DNS is PTR records. They're normally used for mapping addresses to names, but in fact it's a pointer. It's a link from somewhere in the name hierarchy to somewhere else in the name hierarchy. So we can use those. And the third property of DNS is something called SRV records, which have been around for about 5 years. They're not new. They're supported by bind8 and bind9. And what an SRV record does is it doesn't just give you the host where a service runs, it gives you the port number. And that just fixes a little oversight in the way DNS was structured. The reason you can't run more than one web server easily on a machine is because they can't both have port 80. And this hard coding that a particular service always has to be on a particular port was just because the directory service doesn't tell you which port to use. When you type www.google.com into your browser, it tells you the IP address of google.com's web server, but it doesn't tell you the port number to connect. So you end up pulling this number out of the air and saying, well, it must be 80. Well, if the directory service can tell you that number, you then remove that limitation and you can run any number of instances of any service type on a single machine, and they're not fighting over the same well-known port. So that is the framework of DNS service discovery. And using those operations, we provide 3 API functions. You can register the existence of a service that you're offering. Clients can browse to find all the named instances of a particular service type that they know how to use. And then at the time of actually using the service, you resolve that name to the address and port number. Because in a world of DHCP or link local addressing, addresses are not stable. Names are relatively persistent and stable, but addresses could change day to day, minute to minute. So that's why the service discovery doesn't find addresses, it finds names. And then at time of use, you resolve the name to an address. So I'll run through a quick example. A printing client knows how to speak the IPP printing protocol, so it asks a question of the network, effectively saying, I speak IPP, who out there knows how to talk my language? Who's willing to talk to me? And it issues this query on the network. In this case, it's .local, which means multicast on the local network. But because this is a standard DNS query, that could be .google.com, and it would be a unicast DNS query to the name server to ask the same question. The answer we get back is, in this case, we've got 4 example records structured like that. And the first label of each of these records is the user-friendly name. DNS host names are traditionally letters, digits, hyphens, no uppercase, no spaces. The DNS protocol itself doesn't have that limitation. It's a convention for host names that you have to type on the command line. And given that you don't type these things on the command line, we're free of that restriction. So any UTF-8, kanji, whatever characters you want are fully supported, and they go in the DNS packets as UTF-8. AppleTalk used to have a structured namespace with name, type, and zone, and we have a similar thing here. We have the first label is the user visible name. The second 2 labels define the service type, in other words, the application protocol that this service uses, and then the rest of the DNS name is the domain where that service is being advertised. A bit more on service types is warranted. A lot of service discovery protocols that have been done before are organized around device discovery. Because as a human being, that's the way you naturally think about things initially, is find me the bits of hardware on the network. You know, I want to connect to a printer, but you think of the printer as being this physical thing. From the point of view of your software, it doesn't care about plastic and metal. It cares about entities on the network that speak a protocol that it understands. And if this is an AppleTalk printer that doesn't do IP, well, then it's not a printer as far as I'm concerned, because I can't talk to it. So don't find me printers, find me things that I can talk to. And a print service might be offered by a computer that's got a USB cable to a printer. So the notion of what really is a printer and what's not a printer is a little bit slippery, but the notion of what implements the IPP protocol is much better defined. There is a list of these registered service types, and it's up to about 250 registered application protocols that are advertised and browsed for using DNS service discovery, or Bonjour, as Apple likes to call it. I mentioned resolving. I'll quickly cover that. So let's say we want to use the sales printer, and that has been set as our default printer. But every day when we print, the IP address could have changed. So at print time, we do this query. We ask for the SRV record, and we ask for the text record. And the SRV record tells us that it's on port 631, at a host called myprinter.local, and by the magic of DNS, it can put extra helpful information in the reply that you didn't ask for if it thinks you're going to need it. So with one round trip to the printer, we get this information. We know the address, we know the port, and the text record contains additional name value pairs. In this case, it tells us that this printer supports the PostScript page description language. A real text record for a printer is about half a K long and tells you whether it does color and double-sided and stapling and all the attributes of the printer. The full support for this third leg of zero configuration networking appeared in macOS 10.2, and it's open source, and it's real open source in spirit, not just in name. The CVS server we have is public. Day to day, anytime any engineer at Apple checks in code, you see it in the public CVS server. So you see things in the CVS server before they actually ship with OS X systems. The code is intentionally written to be very, very portable, so it runs on POSIX systems like Linux, like Solaris, like FreeBSD. It runs on Windows. It runs on Windows CE. It runs on VxWorks for little embedded devices. And there's a simple adaptation layer. So the core code needs to send packets, receive packets, set timers for future events. And if you want to run this on a different operating system or a different environment, you just have to implement that adaptation layer. One of the things that plagued AppleTalk was a reputation for chattiness, and that was somewhat deserved, somewhat not deserved, but we want to avoid doing that. So one of the things that does differentiate Multicast DNS from AppleTalk is very, very aggressive techniques to limit the chattiness on the network. There's opportunistic caching of everything that the responder sees in case you want to know about that later. When you do a query, you list the answers you already know, because in AppleTalk, you would query for the list of laser writers, and you might get 20 responses. But because packets get lost, you retransmit the query, and you get the same 20 responses again, over and over again. In Multicast DNS, we have a way of listing the known answers so that all those guys don't answer a second time, and it gives the machines you missed the first time round a chance to answer without being stomped on. When you've got a lot of machines on the network, you can get in the situation where the fast ones always beat the slow ones, and then the slow machines are the ones whose packets get lost when the queues overflow. So you can get systematic failure where the slow device is always being missed. So actually suppressing the ones you know about and giving the slow ones a chance to answer is very important. We have duplicate question suppression, so if I browse for printers and then you want to print, you don't have to do the same query because it's already in your cache. Lots of other techniques. We don't query the network at a steady rate. We do exponential back off. So if you leave the printer browser running, it'll back off to 1 query per hour. So it's very light load on the network. Now, if you're querying once per hour and you plug in a printer, you want to know about it. You don't want to wait an hour for the next retry. And we don't have refresh buttons and things in the user interface because that would just be horrible. So when a new service comes on the network, it announces its presence so that it shows up immediately in browsing clients, and then those announcements have a similar exponential backoff. So lots of things like that. With the long TTL in the cache, you run the risk of having stale services remain after somebody's turned the printer off, it's still showing up in the list. So one way to solve that is to have a short time to live, so things expire quickly, but that costs you in terms of network bandwidth. So we took a different approach where we let things stay in the cache, but when you try to use them and the connection fails, we use that as a hint to feed back into the cache management algorithm to say, I think this thing that you told me about is actually gone. Can you check again for me? And then taking that even further, the other clients on the network witness your failure to use this service and your attempt to reconfirm its existence, and they update their caches as well. So typically, what happens if somebody does unplug the printer is you try to print, you fail, you look back in the list and it's gone. You now have a mental model of what happened. You say, oh, somebody must have turned the printer off. The truth is they turned it off half an hour ago. But the point is, you have a mental model that doesn't make you frustrated. If you try to print and fail and you look back in the browser and it's still there, well, then you start getting annoyed with the computer. So this is kind of self-healing. Everybody else on the network gets their list updated, so only one person goes through this and everybody else gets the benefit. There's a question back there?
Yeah, could you comment on how the other clients are getting their list updated? I haven't heard any mechanism described so far.
The question was how the other clients get their list updated, and the answer is that as well as sending queries by multicast, we send answers by multicast as well. So all clients are party to the exchange that's going on. They see the queries, they see the answers. When they see the answers, they cache them. When they see a query that doesn't yield an answer they were expecting to see for that query, then that gives them a hint that that data in their cache is probably false and ought to be purged. So this is where I will show a bit of my demo hardware. And I know today that Google's main business model right now is in the wide area services. But I predict that in the future, with the way Google is getting to so many business areas, right now your focus is getting information to a web browser on a desktop computer. But that's really just the tip of the iceberg. And when we start looking at video and images and music and wanting to get this data to all kinds of devices all around the house, to the television, to the hi-fi, to little tablets that you carry around, to things we might not have thought yet, then the ability to seamlessly throw all this stuff together and have it self-organize and self-configure is going to be critical for those products to succeed. And many attempts to do things like that today, things that plug into your hi-fi and play music, have just been horribly, horribly difficult to use. And if you look at the reviews in magazines and on the web of these things, the journalists are absolutely scathing. I've seen reviews where a journalist spent an afternoon struggling to get a particular music player to work and then just gave up. And the review was not that it was hard to use, but he couldn't make it work, and he sent it back. So let's see. I'm going to start off with one of my favorite things. This is a little network camera made by Axis, and one of the other reasons that this is one of my favorite things is that it also does power over Ethernet. So no power brick. You just plug it in, and I run Safari, and this thing runs Linux. Ah, okay. Let's do... So this thing should be booting up now. There you go. And one of the reasons that USB is popular is because you just plug it in and it works, and for low power devices you don't need a power brick. And now I know that USB is entrenched and I don't expect that to change, but in sort of some fantasy academic parallel universe, if we'd done this about 10 years ago, then maybe we wouldn't even need USB for many of these things today, because ZeroConf provides the plug and play for this, Power over Ethernet provides the power. You've now got something that is every bit as easy to use as USB, except the cables can be 100 meters long and the speeds can be a gigabit per second. So you've got something much, much more capable than USB without sacrificing the ease of use. So I plug this in. I have no DHCP server. I don't know what its IP address is. I don't care what its IP address is. I don't care what its name is, because Safari just found that we have a network camera, Axis 211. And what Safari did there was, when I clicked on the Bonjour list, it did the browsing operation I talked about. It said, what out there on the network speaks HTTP? And the camera said, I do. So Safari displayed the name. And now when I double click here, now, if any of you have spent the afternoon it normally takes to get a network camera working, you'll appreciate what I just did here. Those of you who haven't are kind of looking at me saying, I don't get what was so special about that. I mean, you plugged it in and it worked. I mean, of course, that's what it's supposed to do, isn't it? And you're right, that is what it's supposed to do. And it's just tragic today that so many devices don't. Now, you know, sticking video in a web page is kind of convenient because the web browser has become the kind of universal user interface for devices today. If it doesn't have a screen and a keyboard, the web browser is how you configure it. 20 years ago, the universal interface was the serial port and the VT100 terminal, and we've moved beyond that. But we do have this problem that without ZeroConf, you don't know what address to type in, which leads us to this crazy situation where things ship from the factory with certain hard-coded addresses, and then the manual tells you what the address is, and if that address is not on your subnet, you have to reconfigure your machine's networking settings before you can communicate with it. And if you were trying to read the instructions on the company's website, you've now just lost your connection to the website, so you can't see the next page of the instructions. And if you plug two of these things in, they can't both have the same address. This is just clearly so much better. But video on the web is it's a pragmatic thing. But the other thing I was very excited about this camera doing is it's a camera. It's a network device. So it doesn't just offer HTTP service. It also offers RTP, streaming, video over UDP, and QuickTime Player in QuickTime 7 actually browses for, if we go open URL and pull down this menu, it finds RTP sources on the network. And what we're now seeing is video not wrapped inside an HTML, HTTP wrapper, but just raw native RTP video streaming over UDP packets. And any application protocol you have can be advertised using Bonjour, using DNS Service Discovery, and clients can browse for that. Yeah, question.
The second camera. So you've got a program and you want to find the second camera and you want to get it right every time.
Well, the question is how you find the second camera. Well, you give the cameras names, if I'm answering your question right, and then even though the address has changed, the names are persistent, so you look it up by name, and that's how you find, I mean, first, second, third, 10th, whatever it is, the entities have names like files in the file system. Does that?
It has to be smart enough to take a configuration string and hold on to it.
Well, this device, it ships from the factory with a default name, but through the web interface, you can then configure it to choose the name that you want. So out of the box, it calls itself Axis 211. What you would do as a typical user, if you have more than one of these, if you were sort of building a security system for your house, you would call them garage, garden, front porch. You would give them user meaningful names. And the web UI is an ideal way to do that. That's very convenient. Question there?
Plug two of these in with the factory?
Before a device, the question is what happens if you have two plugged in? Before a device advertises its name, it does a query. And if something answers that query, then it appends -2 on the end of the name. So out of the box, if you plug 10 of these in, they become Axis 2, 3, 4, 5, 6, 7, 8, 9, 10. But if you have that many, your first step is typically to rename some of them. Now, you don't have to. If you've got two, and you've got Axis and Axis 2, and you know which one is which, then Axis 2 may be a perfectly fine name for you. So there's no obligation for you to change it, but there's that option if you'd like to give it a user-meaningful name. Question at the back there?
Does that name have a timeout? Like, so if, let's say, both of those queries go out at the same time, both of them don't get a response back, there's nothing at that name yet. They both pick the same name.
The question is about the race condition, if two devices do it at the same time. And at the end, I'll show the URL, but there's a URL, zeroconf.org, which has links to all the documents and specifications and the other related websites. But when two devices query, they see each other's queries, and seeing another simultaneous query for your name is also treated as a conflict that is resolved with a tie-breaking algorithm. Yes?
On the user experience, is this just an extension of the USB plug-and-play experience, or is there anything beyond?
Is it just an extension of USB? I would say it's a lot more than just USB, because you can have many more devices. You're not limited to 6 feet of cable. Because this is IP, it's agnostic to the underlying communication hardware. So it can be Ethernet, it can be 802.11 wireless, it can be IP over Firewire. In future, it can be whatever new things the hardware guys invent. And that's the great benefit of using IP, is that whenever a new piece of hardware comes out, it inherits this huge wealth of IP-based application software that's already been written. You bring out something like Bluetooth, which is emulating a serial port. It's not an Ethernet-style packet interface. It's a virtual serial cable. Well, Apple had to write the Bluetooth file exchange tool. And doesn't the world have enough file exchange tools already? You know, we have FTP, NFS, we have Samba, we have Apple Share, we have SCP, right? Which this is an infinite list of. What we need is. We could actually use, and you're spot on there. The same is true of printing protocols. That we definitely need a good IP printing protocol.
One more.
But let's do it once and get it right, and not have to keep reinventing the wheel. That's my point, and I think we agree on that. So before we run out of time, let me quickly run through some of the other stuff I have here. So one of the things I told you was you can do this wide area as well as .local. So if I turn on my wireless interface here, and in the Bonjour preference pane, I have added my home domain, stuartcheshire.org, in my list of default browsing domains. And what this just did here was, unknown to Safari, it did a call saying, I want to browse for network services of type HTTP, and the code behind the scenes did a DNS query for http.tcp.stuartcheshire.org, and these are just some example ones that I sort of put for illustrative purposes. None of these advertised services are actually coming from my house, which is one of the things I wanted to illustrate. So I can, you can include references to any host name and port and service you want. So we can double click that, and it's going to take us off to the BBC website. But any organization can advertise static services like this just by typing the lines in the DNS file. So when you stay in the Hyatt Hotel, they could advertise some static pages all about the hotel. You know, they have that television channel that tells you about the restaurants and the gym and the swimming pool and things. Well, they could do a very similar thing where they have a web page about the hotel. San Jose Airport could have a web page announcing flight departure times. And because it's so location-based, they could actually fill that with advertising for the bookshop and the coffee place, because they know you're sitting in the airport waiting an hour for a plane to catch, so maybe you would want a coffee. So there's lots of opportunities there when we have a way to communicate with the users. In the days of Unix machines, there was a message of the day when you log on, and now with laptops and DHCP and wireless, we've lost that kind of message of the day ability to communicate with the people who are connecting to the network.
Not sure I follow what's going on here. How far out into the internet are you going?
The question is, how far out into the internet is this going? Obviously, it's not querying every name server in the world. What it's doing is, if the DHCP offer contains a domain, then it will query that domain. And the user can also manually add domains, as I did, to manually augment that automatic search list. So if we looked with the packet sniffer here, when I ran Safari, you would have seen a query go to google.com, because I'm assuming google.com was in the DHCP packet, and if google.com's name server said, I have nothing for you, then nothing gets displayed. But that's the bootstrap mechanism, how the client knows which domain to query. So actually, I'll bring that web page up again, because I can use that to show another little example. If you've ever tried to use a network printer, you'll probably have experienced the grief with that. It's as bad as a network camera. So let's I'm actually going to delete this printer, because I want to show you. This is interesting. I'm actually finding all of Google's Bonjour printers in this building. Let's. I actually want to. I'm going to delete that. Okay, so that's more like the configuration a user would get out of the box. They've got their new computer and they don't have a printer and they want to print something. And this is the little Apple Airport Express base station. It looks like a power brick for some, sexy Apple product, and it is a power brick, but it's also a wireless base station and a print server and a music server in the same housing. I'll plug it into here so you can see it. Before I do that, maybe I'll show you one of the other things it does. I'll show you the music as well. I think I'm okay. I didn't actually have one of these still in the wrapping today, but one of the things I like to do is get somebody to time me actually taking the shrink wrap off the box and getting it out and plugging it in. So this is factory default. I haven't set it up. I plugged it in, and well, that's, I'll try.
You might be running into a security feature of our local access points.
Well, it shouldn't block the ability of this to.
I might be surprised.
I think maybe FCC regulations about the unlicensed spectrum. It's unlicensed for a reason, but well.
Take it outside the window. It might work.
It definitely looks like something is blocking the wireless, but I'll do it over Ethernet instead. So I'm sure most of you here have seen iTunes, and no, it was just a bit slow, I think. So in iTunes, I just pull down this menu here. I select the new sound output device. I click play. And normally this takes me about 90 seconds, including getting the cellophane off the box and unwrapping it all. And if any of you have tried to set up some of the UPnP home media players, you'll know it takes you more than 90 seconds from shrink wrap to having music coming out. So that's the music side of it. Let's go back to the printing. So we still have no printer selected. Failed the is it plugged in test. Let's connect the cable. So I plugged the printer into the USB port, and we'll see now what else do I have to do. Do I need to run some wizard, some setup assistant? Do I need to reboot anything? No. So as soon as that finishes booting up, under Bonjour printers, there's my printer. I click print. So that is the out-of-the-box experience. Now, in this case, I'm using a USB printer plugged into an airport base station. But if you buy any network printer made in the last couple of years from pretty much any printer company, HP, Lexmark, Canon, Brother, Xerox, I'm probably missing some, they have native Bonjour support. They advertise themselves, they show up in the print menu. And if they have web configuration pages, then they show up in Safari. So in the question is about drivers, and this actually comes back to like the question earlier about file transfer protocols. What the world desperately needs is a good network printing protocol over IP, and that's kind of a layer above Bonjour. The idea of Bonjour is that it's a foundation to let people build application protocols. Now, I am working with the printing team at Apple, and we are trying to work on that. But I make a distinction that that's not Bonjour, that's a printing protocol. What happens right now is because all the printer makers want to differentiate their products, they all have a different driver with different features and different color matching. And I think they feel that if there was just a standard protocol for printing, then they wouldn't be able to innovate. That the real answer might be that we need printers to support some basic protocol for guest printing. Somebody comes to your house and they just want to print a document, and they don't care about perfect color matching. They just want, they want to print out, the Google Maps driving direction so they can get home, and it doesn't have to be color correct. But at the same time, the printer makers can make drivers that you can install if you do want to use the extra optional features. That I think is the answer to that. PostScript is a good answer. But PostScript doesn't appear in low-end printers. When I go to conferences and IETF meetings and things like that, I just look in the print dialog, and all high-end printers do PostScript, and PostScript is PostScript, and I can print typically at an IETF meeting. What you're printing is 80-column monospaced text. It's not exactly the most challenging print job. This is the Roku Sound Bridge. I think this is $99 now. this sort of works the other way around. Instead of the Mac pushing music to this, you kind of attach this to your hi-fi. It's got a little remote control on its display. Afterwards, people are welcome to come and talk to me, and we can play with some of these things. Here's one of the newer Axis cameras that's even smaller. This runs Linux. You can telnet to this and run Emacs and edit the configuration files and things. Some more print servers. Here's a parallel port one. Here's a little USB one. This one is smaller than its own power brick, which is pretty cool. I mean, if anything is just like crying out for power over Ethernet, it's got to be this, right? This is USB in one side, Ethernet the other side. This is a print server. This is one of my favorites. This is a serial port to Ethernet converter. And they love this in the data centers, where you've got all this old rack-mount equipment with serial ports on it, and you end up running these waterfalls of serial cables everywhere to go to some terminal concentrator or something. Well, with these, you just click them into the Ethernet and the advertised telnet service that shows up in, those of you who've got Macs around here may not have seen this in terminal, but if you go connect to server, then you get this little browsing window, and here are some machines here at Google that are advertising themselves as telnet service. Now I still need a username and a password to connect to them. And Rose is my machine at home, because with the wide area browsing, it's showing up there as well. So this thing shows up in the telnet list in terminal. But the reason I love this is we had one of our Bonjour presentations at Apple, and I was proudly saying how the code is only 100K, and in this era of multi-megabyte bloated applications, I'm feeling pretty smug about that. And the guy says, no, you don't understand. This has got 16K of flash memory, and of that, 9K is the HTML pages of the web UI that I serve up. And in the remaining 7K, I've got Ethernet driver, ARP, IP, UDP, TCP, DHCP client, DNS client, telnet server, web server, and you have 700 bytes left to do Bonjour. So forget my source code. We go to the whiteboard. We kind of brainstorm the absolute most cut-down implementation we could think of that might not have all the optional efficiency features, but would generate the right packets, and he did it. And this is called the Site Player. And if you go to siteplayer.com, that's where they sell these. And this is a Bonjour device. And it may not be the most sophisticated Bonjour device in the world, but he did it in 800 bytes. So that was pretty cool. It is now 12 o'clock. So those of you who've got other meetings to go to, I won't be offended if you take off, but I'm happy to stay here and answer any more questions. All right, let's take on next. Yes. Why is the download 14 megabytes for Windows? There's something about Windows installers, and when you localize it for 26 languages, you end up with lots of duplicate copies of the code there, and it should be more like about 1 megabyte, but I personally don't know how to fix that. If there are some people with Windows expertise that know how to slim that installer down, that would be good. Question over here.
Are you familiar with Avahi?
Am I familiar with Avahi? Yes, Avahi is a GPL open source implementation of the Bonjour protocols, and it's absolutely great, and not as good as mine, of course, but actually the rate they're going and the rate that they're adding new features and fixing bugs, they could well overtake Apple's implementation. They're really good guys, and they know the protocols inside out. And we talk to them on a regular basis because they find timing errors that we have in race conditions and ambiguities, and we're working together with them.
Can you browse services from other browsers like Firefox?
Can you browse from Firefox? Well, that was actually one of the things that I was hoping to talk about today, because somebody from Firefox works at Google. Hello. Yes, we have Bonjour browsing in Safari. With the Bonjour for Windows plugin, we have it in Internet Explorer. But Firefox is clearly the dominant force in web browsers today, and may not numerically eclipse Internet Explorer. but in terms of impact that it's having, and the fact that it runs on Mac and Windows on Linux means that it's something that I really, really want to get a Bonjour browsing menu into Firefox.
Can you advertise a default route service that somehow get from your local area connection to an internet connection? Obviously, zero conflict, that could be a natty gateway type thing.
Can you advertise a default route? Well,
network case where you plug a modem in or something?
the answer I have to that is we're really trying not to compete with existing technologies that work well, and a home gateway with a DHCP server in it is a perfectly fine way for a client to get an address and get a configuration, get the name server address and all the other information it needs. So at the addressing level, we're not competing with DHCP. Link local addressing is the safety net for when DHCP isn't there. The multicast DNS and the service discovery are useful and still applicable, even if you do have a DHCP address. But the addressing is there as the fallback for DHCP, not as a competing replacement for it. The question is about the .local TLD, and I could do a whole hour-long talk about IETF politics here, but there was a lot of controversy in the IETF. The DNS extensions working group felt that local namespaces were a bad idea. They thought that RFC 1918 that defines the net 10 and the other private address spaces was a bad idea, and they said that DNS would not make the same mistake that RFC 1918 had made. Now, their view is that every device in the world needs a globally unique name. NAT is evil, private addresses are evil. The point of the internet is that everything is reachable from everything else. And I completely agree with that goal. That's a wonderful goal. That's what the internet should be. And things like NAT do really interfere with the ability to make good products. Things like iChat AV for the video conferencing has to go to extraordinary lengths to try to work around the problems that NAT creates. And even then, it doesn't work all the time. So I have a lot of sympathy for their point of view. Where I disagree with them is, in order to just print this page, my printer did not need a globally unique, globally addressable DNS name that I pay $35 a year to register.com for. And that was where we disagreed. And they said, well, don't use IP, use USB, right? It's almost demeaning to the grand IP to be used for such a mundane local communication task. Some lesser protocol should do that. And really, it was the purview of the DNS extensions working group to define the standards for how DNS work. And they abdicated that responsibility and said, sort of, let chaos reign. And that's a problem. Now, the reality is that with all the printers and the cameras and the Macs and Bonjour for Windows and everything doing .local and Linux as well, nobody is going to allocate .local right now because it would just cause chaos. But I wish it hadn't turned out that way. You know, I wish we could have done it more with the support of the IETF community.
Do you have a certification program for devices?
Do we have a certification program? Yes. If you go to, in fact, I was going to, where's my, oops. That's my final slide. The zeroconf.org website is a good place with links to the other ones. Apple's public-facing website is apple.com/bonjour. The developer-related information is developer.apple.com/bonjour, and that's where you'll find the conformance test. So if any one of these devices wants to put the Bonjour logo on the packaging, they have to run that conformance test. There's no cost for that licensing program. It's purely Apple wanting to maintain the standards so that when you as a customer see the Bonjour logo on a printer, you know that it really means something and it's not going to be a frustrating experience, because Bonjour needs to stand for more than just sort of a checklist feature. You know, yes, we implement this and this and this, but it's turned off by default. Well, if it's turned off by default in the factory, then it's not providing any benefit to the user. So we have some requirements, like out of the box, the printer has got to show up. And if you do all of those things, then you get to use the logo. All right, I'll take one last question there.
You mentioned Avahi. Would you mind briefly giving the state of the rest of the independent implementations or Apple's equivalent to the independent?
I don't know all of them anymore. This thing is sort of mushroomed so big that I don't actually know everything that's going on anymore. Avahi is the best one I know. Arthur Van Hoff of Marimba and Java fame did a complete Java implementation of Multicast DNS. Novell did one entirely in C#. There are others I've heard of that aren't really complete, but Avahi is the one that I know of that really does challenge Apple's in terms of its completeness and its robustness. All right, well, thank you all for coming.